Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up number 16 is on the screen. And notice we still have the 3 that we've been reviewing, but I added one more. And as we continue throughout the year, guys, that's how it's going to go. I'm going to be adding like little things on the warm-up that are going to get us ready for the next concept that's coming up. So I'm just giving you some practice first, which is number 4. Including numbers 1 and 2 as to what's coming on the next concept that we're going to cover. So I'll give you some time for that. Go, just to make sure we got it. All right. Brandon, Felix, go. What'd you get for number 1? Yeah, just the answer. 12x power 2 y, okay, minus 4y. Minus 4. Hands, have you got that? That is correct. Let's go. Number 2, I'm not going to go through the process, but you should have used one of the 3 methods. What are the 3 methods? Distributive property, or area model, or vertical multiplication. Now you have 3 different ways of doing it. Pick the one that you like, and you should have multiplied that one because this one's not combining. So, show your neighbor what you got for that one, and Brandon's going to pass it to someone. Number 2. All right, pass someone, Brandon. All right. Jaden, what'd you get? $12x to the 3rd. Hold on. 12x to the 3rd. What else? Is that it? Close. All right, so let me go over this. Here it goes. I'm going to multiply this one times all 3 using distributive property. What is x squared times 4x squared? 4x to the 4th. Next, x squared times 8x. 8x to the 3rd. X squared times 4, that is 4x squared. I'm done with that. I go to the second term times all 3 again. Negative 5x times 4x to the 2nd, that's negative 20x to the 3rd. That is negative 40x squared. And that is negative 20x. So far so good? Yeah? And then from there, combine like terms. Is there another x to the 4th? No, bring it down. 4x to the 4th. X to the 3rd. Let's go. Yes, we got negative 20 plus 8. That's negative 12x to the 3rd. Then we got 4x squared. Negative 40x squared. That's negative 36x squared. No hezzies. Come on, man. And negative 20x. Hands, have you got that? Let's go. Oh, yeah, we got this. All right, and last but not, number 3. Share with your neighbor what you got for that one. Answer only. Answer only. All right. So since I went over number 2, I get to pick, yeah? How about Martin? Number 3. Answer for number 3. Negative 20 less than or equal to x less than negative what? Negative 3. Let's see. That is correct. Let's go. Yeah, or did I make a mistake? I did okay, right? No? Let's see, plus 15, that gives us negative 6. Yes? Plus 15, that gives us 40. And at the end, we divide by negative 2. Divide by negative 2. Oh, this is a positive. Oh. How about that? Yeah? All right. And number 4, let me go over number 4. Here it goes. I'm going to, and let me pause the beats in the back. I'm going to go over this step by step just to make sure we got it. And some of you are like, Mr. Q, we saw this in 3rd grade. You guys remember your teacher? We're going to make a factor tree. Remember that? No? Some of you remember? No? Anyways, the way I ask students to look at this is as follows. Look up. I want you to first think of the number 15 and then find pairs of numbers that multiply to give us that number. So, for example, I start always with number 1. 1 times what gives us 15? 15. 2 times, nothing. 3 times, 4 times, nothing. And then 5, and then repeats. So the only 2 pairs are those. I'm going to do the same for this one. 1 times 12, 2 times 6, 3 times 4, 4 times 3, and then it repeats. All right. So, question, from those, which of those numbers do both of them have in common that's the greatest number of all? The 3. That is correct. So the GCF is 3. That's how you find GCF. I'm going to show you a different way pretty soon, but that's probably the quickest way of getting there. Okay? All right. Copy the agenda for today. Here we go. Agenda for today, warm-up number 16. Today we're still working with product of polynomials. Today we're working with a section that sometimes could be a little bit of confusing for some, but not for us. We got this, right? We ate our morning breakfast and such, so we're ready to rock and roll. We got this. And your home plate for tonight is only numbers 12 to 22 only. 12 to 22 only. So I'm going to give you a Nearpod code so like that you have it because you're going to need it for the home plate. So since we already turned in your home plate for tonight, from last night. Hold on. Here's the code. Copy this. 4Y9GS. 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 So in case you missed something from the presentation, just go there, and also for the home play for tonight. Okay. So once again, last night's home play, make sure you had turned that in on Canvas. I'll give you guys about 30 seconds, those of you that haven't finished turning that in. And once again, we selected 5, 7, and 13 to do all 3 ways, right? Yes? All right. Was that plenty of practice? Yes? All right. And tonight, we're going to be going over these, and that's why, giving you a heads up, like I said, some of these give us problems. Get it? Problems? Like, no? Anyways, that's why we're starting, we started with tutoring yesterday. I said yesterday. I didn't get any customers, but today, if you need to stop by, I'm going to be here after school. What do we do during tutoring? We actually go over this, and you're done with it before you go home. So, there you go. Okay? We good? Yes? All right. So with that said, get a Cornell note ready. I can multiply polynomials. I can multiply polynomials. I can multiply polynomials. Once again, like I said, for the rest of your career in education, if you are taking mathematics, pretty much you're going to be looking at polynomials. Go to Starbucks. Yes, Starbucks, can I take your order? Yes, let me have a doppio iced with a splash of half and half, heavy cream, and 2% with a little sprinkle of cinnamon. And give me some polynomials on the side. I'm telling you guys that they're not going to leave, so you guys need to get acquainted with them, okay? All right, and yeah, do you guys know what a doppio is? Yeah? It's 2 shots of espresso, and ice, and then just add the splash of what I mentioned, and it's only $2.50, I think. On the Bentayg, let's go. All right, tell your neighbor the definition of polynomials. They should know by now. If not, ask them for $5. Polynomials. All right. Who did I pick last? Martin? Martin, pick someone for definition. Danny. Sum and difference of monomials, but also included monomials. Yes? All right. Yeah, I'll take that. There it is. So far, so good. Yeah. And here's today's. Writing utensils down, look up to the screen, close your Chromebooks. You do not need them. And this is where, like I said, some people might get challenged. I don't want to say confused. It's more challenged. All right, here it goes. Look at this. This is a pattern in polynomials. What does that mean, Mr. Q? Look up so you can understand. What this is saying, look up, is that this is being multiplied how many times by itself? Twice. So that means x plus y times x plus y. Do we know how to multiply? Yes. Distributive property, yada, yada, yada. We do a bunch of stuff. And at the end, we should get what? This. So this is giving us an actual, a cheat code that you guys call it in gaming, right? So you go straight from, if you see something that looks like that, then you already know to write the answer like that. Okay? Here goes another one. What's the only difference? That this one's addition, the middle term has addition. This one has subtraction, the middle term has what? Subtraction. Here goes the third one. This times this, at the end, once we multiply them, we end up with this. All right? And these are called polynomial identities. Polynomial identities. Copy those, please. Polynomial identities. Today we're going to be working with those. I'm going to show you how to identify some of those using regular numbers. Regular numbers. Let's go. So, patterns. So basically, this I'm going to give you for you to multiply, and it should give us this as an answer. Now, to prove that that's true, let's go to number one. Copy this. Example 1. Verify that this is equal to that. Copy that really quick. We have parentheses x plus y squared equals x squared plus 2xy plus y squared. All right, let's do this one together. It says verify. What does that mean? What's another word for verify? Check. Another word for verify means what? Check. So we want to check that this is equal to what? To that. So how can we verify? Well, first we need to rewrite this. Look up. What does it say? It says this times itself how many times? Twice. So let's write it underneath. X plus y times x plus y. All right? So do we know how to multiply that? Which method would you like to use? Vertical, area model, or distributive property? Take a vote. Vertical, area model, distributive property? Oh my goodness. Fine. All right, here we go. Let's start with x times x and times y. What is x times x? X squared. What is x times y? xy. Okay. Next, we go with the second term, which is y. What is y times x? In alphabetical order. xy, and what is y times y? Y squared. Are we done multiplying? Yes. Now we combine, yeah? Is there another x squared? No, bring it down. Is there another xy? Yes. So here's 1xy plus 1xy. How many do we have? 2xy. And then we bring down the y squared. Question, did we get this? So then all you have to do is point to it and write verified. Verified. Simple as that. And your noodle should be asking, well, what if it doesn't match, Mr. Q? Then you write not verified. Right? All right. We got it? From 1 to 5, I'll come through you with that. Let's do another one. Copy this one. Example, do that one. Example 1, Q. parentheses x minus y squared equals x squared minus 2xy plus y squared. Let's make sure that this is equal to that. I'll give you a head start. Go. All right. So, just for the sake of practice, first I'm going to rewrite it. And everybody, how many times itself? Twice. So you should have written x minus y. And then we're going to do this using the area model. How about them apples? Pretty good, yeah? You're like, oh yeah, my favorite, Mr. Q. All right, good. So we got, what goes here? Help me out, David. What goes here? X minus y. And then we got x minus y. So, let's see. What is x times x? X squared. X times negative y. That's negative xy. Then I go to this one times these two again. Negative y times x in alphabetical order is negative xy. Negative y times negative y is positive y squared. So, combine like terms, there's only one x squared. Combine these, that gives me negative 2xy plus y squared. And what did you write? Verified. Yeah? Pretty good? Yeah? So you're like, what's it say, Mr. Q? My bad. Okay, let me rewrite it. There you go. Better? Anyways, you get the idea, yeah? All right, from 1 to 5, I'll come to where you were at. All right, good. Have I shown you my signature? No? Here, let me show you my signature. Let me pause the video because I don't want people to this. All right, so let's go to another one. Yeah, let's do this one. Example 1, super Q. X plus y times x minus y should equal to x squared minus y squared. All right, and notice they already wrote this side in parentheses, so you can start doing the multiplication. So I'll give you a head start. Go. All right. Let's see. Help me out with this, Anthony. D. What do I do first? All right. So we get. All right. And then. And that gives me. All right. Anthony got it to right there. Okay, not bad. Bring this one down. Combine this one with this one. And since they're opposites, that's a zero pair, yes? And we're left with negative y squared. And what do we write? Verified, yeah? Got it? Let me write it nice for you guys. Damn. I have to slow down a lot. Yeah, one of the, man, later on I'm going to tell you a story when I was in 5th grade. I'm never going to forget. Well, I'll tell you right now. So anyway, it's being recorded. I remember I got home. I was in school, and yeah, I know. And I was and I grew up in Mexico, and over there I was at a school that they were very strict, like even stricter than Mr. Sanchez, like straight up and down like that. You're like, what? Oh yeah. So one of those days, the teacher wrote on my notebook, Pedro, work on your penmanship, please. I said, okay. So I was going to practice some more, right? And I forgot it was a Friday. Here comes Saturday morning. And Saturday mornings, I usually woke up to watch my cartoons, get some cornflakes, you know what I'm saying? It was one of those days. And I hear my grandma, Pedro Quintanilla. I'm like, oh, snap. So I'm like, I open the door from my room, and I look down the hall. She has my notebook on her hand, and she has a belt on the other hand. I was like, oh, what did I do? I totally forgot, like, what did I do? So I got closer, what is this? And I'm like, I don't know. What is this? So I get closer, and then I see the note, and I'm like, oh, they just want me to practice my... Started dancing. Let's go. Yeah, I got a whooping. Oh, my God. Yeah, my grandma was like, yeah. And she had a heavy hand, too. One time she smacked me across the room, like, and I'm pretty big. So imagine, like, she was a little stocky lady, but she had a heavy hand, you know. Anyways, that's the story with, that's why I learned how to write really nice but very slow. So, anyways, let's continue. Shall we crank it up a bit? Bam! Example 1 mega Q. We got x plus a squared minus x minus a squared equals 4ax. Oh, okay. Yeah, let's do that. So we got x plus a squared. So that means you're going to do this one. You're going to write it here. And then this one there, bring the negative down about right there. So like that, when you multiply and do all the multiplication goes here, and then combine it, leave it here, multiply it, combine, and then at the end, this one, we have a negative that's going to distribute at the end. You're like, all right. So, x plus a, x plus a. So we said Brandon was going to help us. All right, Brandon, Doherty, go. X times x, x squared, x times a, ax, all right. A times x, and a times a squared. All right, let's combine. Bring this one down. 1ax and 1ax, that's a total of 2ax. And then bring down the a squared. All right. Next, we got x minus a, x minus a. All right, Brandon, pass someone for somebody to help me. Brianna. All right. That is. And then x times negative a is. And then we got negative a times x. And negative a times negative a. All right, and we combine. Bring this one down. These two, negative ax and negative ax, that's a total of negative 2ax, yes? And then bring down the a squared. Now notice, look up really quick, notice that I put this one in parentheses. Why? Because we need to remember that we need to distribute this into the parentheses, is that correct? But we don't do it before. We do it once it's multiplied, now we distribute. All right, make a little note for yourself here, asterisk, heart, Make sure you remember to bring down that negative till it's multiplied. Now we can multiply the what? Negative 1 in here. So what is negative 1 times x squared? That's negative x squared. Negative 1 times negative 2ax is positive 2ax. And negative 1 times a squared, that's negative a squared. So far so good, yes? All right, now we can combine. Let's see. Is there another x squared? Yes, it's a negative, and what happens? 0 pair. All right. Then we got 2ax and 2ax. That's a total of 4ax. And then we got a squared and negative a squared, and that's a what? 0 pair. Did we get that? Yes? Yes, Mr. Q. All right, good. So, from 1 to 5, how comfortable are you verifying stuff? 1 through 5, 23, I see that. 5 fours, okay. Because in the home plate, check this out, you're going to have stuff that looks like this. They're going to do something like this. Parentheses, blah, 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 times parentheses, blah, 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 times parentheses, blah, 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 equals 2. And then they're going to give you whatever over here. So just multiply the first two, then multiply whatever you get times that third parentheses. All right, enough messing around. Let's go to simplify this a little bit more. Here it goes. Use some numbers. Copy this, please. And I want you to write where it says rewrite numbers as binomials, and then copy A. They're all A's. What? My goodness. A, B, C, D, and E. Change those to different. Let me change it. This is B, C, D, and E. Just copy them, and I'm going to go over the first ones, and you should be able to do the other ones by yourself. So I'm going to write the first one as a binomial, but without a variable. You're like, what do you mean, Mr. Q? Yeah, you know that binomials have how many terms? Two parts. Usually one with a variable, one without a variable. But I'm going to do this without a variable. So look up to the screen. Write your utensils down. An easy way of thinking about this one, is saying 12 is the same as 10 plus 2. Is that a binomial? Yes, because it's got how many parts? 2. The 10 and the 2. However, some of you are like, Mr. Q, but what if I want to use 20? All right, so then it would be 20 minus 8. 20 minus 8 is 12 as well. Are we there so far? Now, could I use any numbers? Yes, but for right now, let's stick to tens. 10s, 20s, 30s, 40s, 50s. Does that make sense? All right, copy that, please, and then we're going to do the next one together. All right, so let's go with 15. So if 12 is 10 plus 2, tell your neighbor what 15 would be. All right, 15 would be what, Brandon, Felix? Let's go, 10 plus 5. That is correct. Yes? All right, so with that said, that's with 10. What if we go to 20s? Tell your neighbor what would it be with 20. All right. Jacob, what do you think? 20 minus 5. Hands, have you got that? All right. So with that said, do number 19 for both. Write them both ways as a binomial using 10s and using 20. All right. Show your neighbor what you wrote, please. Make sure they have the same thing or something similar. All right, you should have written what? 10 plus 9 and 20 minus 1. All right. Go to number 23, Michael Jordan. Oh, yeah. Best ever. Let's go. Write that one, and then go to 87 and write that one. Let's see what you get. All right, show your neighbor number 23 and then number 87. See if they have something similar to you. All right, let's see, Selena, 23. And what else? Let's go. Hands, if you got that. All right. How about 87? Pass someone. 14, Gene. 80 plus 7. 90 minus 3. Hands, if you got something like that. That is correct. All right, so now that we know how to write these, let's use now identity properties, but with numbers. This is where it gets interesting, so stay focused, please. Here we go. Copy this one, example number 2. Number 2. It reads, find the product using one or more of the following identities. You're like, what? Yes. So, 12 squared. Here goes the process. Let's do it together. First step is we're going to rewrite the number as a binomial. So, how do we write 12 as a binomial? Everyone? 10 plus 2. And then we write it squared. Okay. Do we know what to do from there? Yes, we can write the 2 parentheses, multiply, but it's a lot of work. So we're going to use our cheat code over here. Question, which of these looks like that? The first, second, or third? The first one. So that means we're going to use this pattern to find the answer. So watch. Instead of x, what do I use? 10. And instead of y, what do I use? 2. So right above that, I want you to write, let's write it underneath. Let's write x plus y squared equals x squared plus 2xy plus y squared. All right, so I'm going to use colors to keep organized. Ready? Here we go. I'm going to use blue for 10 and red for 2. Or in other words, for the x, I'm going to use what? Blue and red for the y. So here we go. So this, I'm going to continue right underneath, but with numbers. So instead of x, what do I use, everyone? Instead of x, what do I use? 10, so I'm going to write 10 squared. Plus 2 times what? What is x? 10. But then times y. What is y? Plus 2 squared, right? Let's simplify this. What is 10 squared? 100. 2 times 10 times 2. And 2 squared is? So what is this? 100 and? Ooh-wee. You're like, what? Yeah, we're just using the pattern of the identities. From 1 to 5, I'll come for you with this. All right. Cool. So that's one way. What's another binomial for 12? Tell your neighbor. Another binomial. Not 10 plus 2. What would be the next one? Next one is what? Kimberly. 20 minus 8. Write that in there, please. 20 minus 8. This is going to be example 2, super cute. And what does that look like? The first, second, or third identity? The second, so let's write it underneath. X minus y squared equals x squared minus 2xy plus y squared. And again, for x, we're going to use 20. And for y, we're going to use what? 8. Okay, I'll give you a head start. Substitute and simplify. See what you get. All right, see what we got. You should have written 20 squared minus 2 times 20 times 8 plus 8 squared. Hands if you got up to right there. All right. Simplified. What is 20 squared? 400. Negative 2 times 20 is negative 40. Times 8, that's negative 320. Then plus 8 squared is 64. So let's combine stuff. What is 400 minus 320? 80. That's this. And what is 80 plus 64? 144. Did we get the same thing? Yes. You're like, what? I know, right? Pretty cool. From 1 to 5, I'm comfortable. Are you with this so far? All right. 5 fourths, 23, Michael Jordan. All right. And the last one. Copy this one. $27 times 33. Hurry up, hurry up. Copy that one. Last one. Give me 30 seconds. Step 1. We need a midpoint between this number and that number. Midpoint. How do we find that? Well, we add these two numbers and divide by 2. So what is 27 plus 33? That's 60, yes? 60 divided by 2, and that is 30. All right, so hold on. That's the midpoint. Now we can rewrite these as binomials. So how can I write 27 starting with 30? Minus what? Minus 3. How about 33 using 30? Plus 3. Does that look like any of these properties? Yeah, the bottom one. There you go. And you just follow the pattern. Let's go. Good one, guys. Enjoy your home play. See you guys tomorrow. Always take your books home. Leave them at home. If you were out in the restroom, make sure you grab a pack before you leave. Also, tutoring after school. If you need extra support, we're going to finish the home play here. See you guys later. Bye.